Good morning, everyone. I am Professor Saraswati Pandey. Today, we are going to understand the working and introduction of microprocessor. So, processor means anything which do work, which process something is known as processor. Micro, it means the size of that processing unit is very small or compact, or by definition wise, we can say a microprocessor is a compact, powerful central processing unit on a single silicon chip, integrating millions of transistors to execute the instruction, perform calculation like arithmetic and logical, and manage data flow from computer or smart devices. It functions as the brain of the device, fetching, decoding, and executing the program. Now, the processor which we are going to learn in the semester is 8085 microprocessor. This is a 8-bit microprocessor. So, what does mean by 8-bit microprocessor? The data that it can fetch is of 8-bit only. So, that's why the name given to this is 8-bit microprocessor, and it was introduced in 1977 by Intel. It was a binary compatible and require less supporting hardware. Binary compatible means it deals with the binary number 1 and 0. Whatever instruction you put, it is going to create the opcode in the binary domain, and accordingly it is going to fetch. And it requires very hardware because it's a single chip per processor, so it's require very less hardware, but it is connected to multiple devices for execution of particular circuit. You need to connect with the other components also, thus allowing a simpler, less expensive microcomputer system to be built. Microprocessor 8085 requires the voltage requirement of this processor is only 5 volts of the power supply. The main feature of microprocessor is that it is a 8-bit microprocessor, and it was manufactured in NMOS technology. It was in the initial days it was manufactured in NMOS technology, that is N type MOSFET. Yeah, or you can say N channel MOSFET. It has a 60, the key features are that it has 16-bit address bus and hence can address up to 216, that is 65536 byte, that is 64 KB memory location, and the address is from A0 to A15. It is first A line are 16-bit address bus, and 8 and the remaining 8 line are multiplex of address and data bus, that is AD0 and AD7. The data bus is a group of 8 lines AD0 to D7. It support external interrupt request. A 16-bit program counter. It has a 16-bit program counter. It has a 16-bit stack pointer. 8-bit general purpose register. It has a general purpose register for transferring the data, for storing the addresses, for storing the result. It has 6 general purpose register, that is BC. B is of 8-bit, C is of 8-bit, and if we together use this two register, it is of 16-bit. Similarly, D and E are the two 8-bit register, and if we are going to use them together, it is going to be a 16-bit register, general purpose register. Similarly, H and L is the general purpose register, and it basically used to store the result. It requires 5-volt supply, as we already said, and the frequency at which it operates is this 3.2 single phase clock. In it is an enclosed, this processor is a pin size. It is a pin type microprocessor which is having 40 pins, and the architecture of this microprocessor is this shown, as shown over here. It is having multiple units. Some is a register unit, or you can say general purpose register unit, program counter. Over here we are having accumulator. These are temporary register used to temporarily put the address or data. and it is the flag register. Flag register is used to tell the status of the result. Then it is a ALU unit, that is arithmetic and logical unit. Is a instruction register. This is the instruction decoder and machine cycle unit. This unit release the timing and control signals. And this is the interrupt control unit. Whatever interrupt signal are coming, it is first fetched by the interrupt control unit. And this is serial in out unit. And at the end, there is a increment decrement address latch. And this address latch is accumulated with address buffer and data buffer, and multiple, these all pins are there, you can see in the pin diagram too. So coming to the architecture, 8085 architecture consists of various unit as shown in figure 1. Each unit perform its own function. The various unit of a microprocessor are listed: accumulator, arithmetic and logical unit, general purpose register, program counter, stack pointer, temporary register, flag register, instruction register, decoder, timing control unit, interrupt control unit, address buffer, address data buffer, address bus and data bus. Now coming to the first, accumulator. Accumulator is nothing but a register which can hold 8-bit data. Accumulator aid in storing two quantities. The data to be processed by arithmetic and logical unit is stored in an accumulator. It also stores the result of the operation carried out by the arithmetic and logical units. So the first 8-bit data which is going to be processed by ALU is being dumped in the ALU first, and the 8-bit result, first 8-bit result which is obtained, is also stored back in the accumulator. The accumulator is also a 8-bit register. Accumulator is connected to the internal data bus and ALU. The accumulator can be used to send and receive the data from the internal data bus. After the ALU, there is an arithmetic and logical unit. Arithmetical and logical unit can perform arithmetic operations like addition, subtraction, multiplication, division. It can perform logical operation like ANDing operation, ORing operation, NOT operation. So there is a necessity of creating separate unit which can perform such type of operation. These operation can perform by the arithmetic and logical unit only. The ALU perform these operation on 8-bit data. ALU, as it is a 8-bit processor, it can process the data of 8-bit only. But these operation cannot be performed unless we have an input data which is desired operation is to be performed. So where to this data reaches the ALU. For this purpose, accumulator is used. As I already told you, the first 8-bit data which is need to be fetched, decode, multiplied, subtracted, added, adding operation, or it is need to be provided by ALU only. And the result after processing the result, the 8-bit result is fetched or stored back in the ALU only. Now there are six general purpose register B, C, D, E, B, C, D, E, H, L. They can be used together when you require to fetch the address of 16-bit or data of 16-bit. You can use as a combined B, C, D, E, H, L, or you can use the separately for 8-bit data processing. Now, the pairing HL to store the 16-bit data. HL pair work as a primary memory pointer. It tells you the status of memory. The memory pointer hold the address of the particular memory location and can be stored 16-bit address as they work in a pair. Now, next is the program counter. Program counter is a special purpose register. Consider that the instruction is being executed by the processor. As soon as the ALU finish executing the instruction, processor look from the next instruction to be executed. as you fetch the first instruction, you start executing, and the processor will fetch the next upcoming instruction. So there is a necessity for holding the address of the next instruction to be executed in order to save the time. This is taken care by the program counter. A program counter stores the address of the next instruction to be executed. In other words, the program counter keeps the track of the memory address of the instruction that are being executed by the processor and the memory addresses of the next instruction that is going to be executed. The processor increment and the processor increment the program where program counter whenever the instruction is to be executed, so that the program counter points points to the memory address of the next instruction that is going to be executed. The program counter is a 16-bit register. Stack pointer is a stack means what? Aligning the things one above the other is known as stacking. So the stack pointer do the work similarly. It is a 16-bit register which is used as a memory pointer. A stack is nothing but the portion of RAM, that is random access memory. The stack pointer maintain the address of the last bit that is entered into the stack. Each time when a data is loaded into a stack, the stack pointer gets decremented. Conversely, it is incremented when the data is retrieved from the stack. So it means what? When you put the data, it is going to increment, and when you is going to retrieve the data, it is going to decrease. Now, the next is the temporary register. When the arithmetic or logical operation is going to take place in ALU, the first 8-bit data is going to be fetched or going to be attained by by accumulator, and the next 8-bit data is going to be processed or going to be attained by the temporary register. As the name itself is temporary, these register is used for temporary storage of the data. As the name suggests, the register act as a temporary memory during the arithmetic and logical operation. Unlike the other register, these temporary register can only access the microprocessor, and it is completely inaccessible to the programmer. The temporary register is a 8-bit register. Now coming to the flags. Flags basically tell us whether the operations were whatever operation you do, arithmetic or logical operation you do, whatever is the status of the result is going to be displayed by the flag register. Flag register is basically a flip-flop which stores data in a binary bit 1 or 0. The flag are mainly associated with arithmetic and logical operation. The flag will shows either the logic or logic set or reset depending on the data condition in accumulator and various other register. A flag is actually a latch that can hold some bit of information in later the processor that some event can take place. So this is a 8-bit register in which we have at the zeroth position we have a carry flag. It is a parity flag. It is auxiliary carry flag. This is a zero flag, and this is a sign flag. Sign flag indicates whether the result is positive or negative. Zero flag indicates whether the if answer is zero, it will be set 1. If the answer is non-zero, it will be set 0. Auxiliary carry flag, when we do 16-bit operation and if a carry is generated, it is going to be set to 1, so to indicate that between the 8-bit there is a carry is being generated or borrow is being taken. This is a parity flag and this is a carry flag. If carry flag is generated, carry is being taken at the 16-bit side, it is going to set. Now there is a instruction register and decoder. Instruction register is a 8-bit register just like every other register of microprocessor. Consider an consider an instruction, any instruction whichever you will going to be process need to be decoded by the instruction register. The command is going to be get by the instruction register, and then only a particular processing is going to be taken place in the ALU. The instruction may be anything like adding of the data, moving the data, copying the data, any data anything which you want to process in the processor, that need to be fetched by the instruction register. And after the decoding of the instruction, the particular processing of the instruction will take place. When such an instruction is fetched from the memory, it is directed to the instruction register. So the instruction register are specifically to store the instruction that are fetched from the memory. There is an instruction decoder which decodes the information present in the instruction memory for further processing. Then there is a timing and control unit. Timing and control unit is the most important unit, as it synchronizes the register and flow the data through various register and other units. These units consist of oscillators, controller sequencer, which sends the control signals needed for internal and external control of data from the self device or the other unit or other devices. The oscillator generates two-phase clock signal which aids in synchronizing the odd register of 8085 microprocessor. Six signals that are associated with timing and control unit are read write ALE. ALE is basically we are having 8-bit address buffer and 8-bit address and data bus multiplex. So when we use need to fetch the data, this ALE signal is used and it demultiplex the address and data buffer. And whenever we need to fetch the data, this ALE signal is used. Then there is read signal whenever we need to write anything in the memory, we use read signal. And whenever we need to read or fetch the data, we use read signal. Whenever we need to write the data, we use our WR signal. Then there are status signal or memory signals. So this is a combination of 3-bit register. When they are zero, you are going to get halt, means you are in a wait condition. The processor is in wait condition. When a memory or IO is zero, means when you can see this is a IO means input output devices, or memory bar means whenever the signal is zero, means memory related work is going to take place. So whenever it is zero, it means it is memory work. And when it is 0 1, memory write. It is 0 1 0, memory read. When it is 1, input output IO, input output write. When it is 1, input output read. When it is 0 and both these status signal are 1, means opcode fetch is going to be taken place. And when all threes are 1, means interrupt acknowledgement is going to take place. Now, what is interrupt? Any external device want to access the microprocessor, then they need to send a signal that is known as interrupt signal. As the name suggests, this control interrupt process. Consider that a microprocessor is executing the main program. Now, whenever interrupt signal is enabled or request, the microprocessor shift the control from main program to process the incoming request. And after completion of request, the control goes back to the main program. Interrupt signal present in 8085 are INT are the highest priority interrupt signal, that is interrupt request. Then RST 7.5 second highest priority, RST 6.5 third highest priority. Then RST 5.5 is the second last priority, and trap is the least priority interrupt signal. A serial input output control unit. This unit basically controls the input output commands of the microprocessor. Input output of a serial data can be carried out using two instructions. SIOD, that is serial input of the data, SOD, that is serial output of the data. The two more instruction that used to perform the serial conversion needed from serial IO devices are SIM, and RIM instructions. Now, address and data buffer, as we all have already discussed, the 16-bit address buff and 8-bit data buffer. So the MSB least significant bit of address bus are multiplexed with the data buffer, and using the ALE signal, they are demultiplexed from each other. Now, address bus and data bus. The address bus present in the microprocessor is of 8-bit wide, and 8-bit of the data can be transmitted to and from the microprocessor. 8-bit 8085 processor requires 16-bit address bus for memory address of 16-bit wide. 8 most significant bits of the address bus are transmitted with the help of an address bus, and the 8 least significant bit are multiplexed with the address and data buffer. The 8-bit data can be multiplexed with the 8 least significant address bus. The address and data bus is time multiplex. This means that for few microseconds, the 8 least significant bit of address are generated, while the next few seconds the same pin generates the data bus. So they are time multiplex for a very small time. The least significant address bus are multiplexed with the data, and after few microseconds the data bus is free to fetch or read the data. This is called time multiplexing, but there are situations where there is no need to transmit both data and address simultaneously. For this purpose, ALE signal is used. ALE signal is address latch enable, and it is used to demultiplex the address and data buffer. Now, this is a pin diagram of 8085. It is a 14-pin IC. It is having all different 40 pins have different function associated with them. It has a supply pin over here, which is of 5 volt. This is the crystal RLC oscillator to generate the frequency. Then it is a ground at 28th pin. This is the 20th pin is a ground. This is the address latch upper 8-bit, and this is the multiplex 8-bit. These are the interrupt signal. This is our serial input output unit signals. Then this is read write hold signals, which are being used for interrupt related or memory related operations. Thank you.